Okay, so we have made it to the final lesson of this unit before the big scary test that I'm still not completely sure, but you know, it's Sunday before this week even started, so that's even for A Day. For B Day, this is the previous Sunday because that's apparently what we're doing now. So, complex fractions is the last thing we have to talk about. Okay, now we have done this. Complex fractions is just a fancy way to say fractions inside of fractions. Okay, so we have already done this with some trig functions previously. So what we're going to do now is move into it just with x's and y's and whatever, just because when we get into calculus next year, it's going to be a thing that happens, okay? Especially towards the beginning of the year. So this is actually pretty important for you moving forward. So let's just look at it. It's not too hard. Basically what we're going to do is we're going to make sure that there's a common denominator on top and a common denominator on bottom. They don't have to be the same. A lot of times they will be. They don't have to be the same, okay? But I want to make sure there's one on top and one on bottom, and then leave, change, flip like I always do with fractions if I'm dividing them, okay? Because a fraction essentially just means division. So let's look at number 1 here, okay? All right, so this one starts off pretty simple. All right, so there is y squared over 4 on top and y over y plus 4 on bottom. So both the top and the bottom of this fraction have common denominators. There's nothing being added in there, like two fractions being added or subtracted or anything. They've already got common denominators and they've already been combined even. So I get to start this problem out by doing leave, change, flip. So I have y squared over 4, maybe, y squared over 4 times y plus 4 over y. Okay? So this y and one of those cancel. Maybe. Okay. Now, I cannot touch the 4's and I cannot touch the other y's because of that plus sign. So the best I got is that this is y times y plus 4 all over 4. Whoever thought it was a good idea to put y's and 4's in the same problem, not very smart, but it is what it is, okay? So that's as good as our answer gets. It's not nice and neat, but it's an answer. Okay, so let's look at a more complex one. All right, so if I'm looking at this. So on top I've got two fractions, technically those are both the 2's over a 1, and on bottom the 3's over a 1. So I've got to get common denominators, and both on top and bottom, it looks like that common denominator is going to be 2x minus 1. All right, so this is here we go. Okay, 2 times 2x minus 1 over 2x minus 1 minus 11 over 2x minus 1 all over 3 times 2x minus 1 all over 2x minus 1 minus 17 over 2x minus 1. Okay, so I got common denominators. So my next step is going to be to go ahead and combine these things. All right, FOIL and combine. So I've got on top there, I'm going to have 4. I'm going to have 4x minus 2 minus 11 all over 2x minus 1 all over 6x minus 3 minus 17 all over 2x minus 1. All right, so I've got my top and my bottom both to just down to one fraction, okay? So when that happens, that's when it's time to leave, change, flip, okay? So this is equal to 4x minus 13 over 2x minus 1 times 2x minus 1 over 6x minus 20. Okay. Now, because I'm multiplying and I've got the same thing on bottom on the left side as the top on the right side, I get to cancel those. So my answer is 4x minus 13 over 6x minus 20. Okay. If that 13 was an even number, I would factor a 2 out of everything and then cancel out that 2 on top and bottom. But since it's not, we don't really get to do anything with it. Okay. Over here. All right, it looks like the common denominator on top and on bottom, both, is going to be the same, and it's going to be x minus 2 times x minus 4. Okay, so let's go ahead and create those common denominators. So this is equal to 3 times x minus 4. That's a 4. No, it's not. Let's try that again. X minus 4 over x minus 2 times x minus 4 plus 4 times x minus 2 all over x minus 2 times x minus 4. Okay, and that's all over. Same thing on bottom. So that's going to be 5 times x minus 2 over x minus 2 times x minus 4 minus 2 times x minus 2 all over x minus 2 times x minus 4. Okay. So I have fixed my fractions to have common denominators. Okay. So my next step is going to be distribute on all those things and combine into single fractions on top and bottom. So let's do that. So I'm going to have 3x minus 12 plus 4x minus 8 all over x minus 2 times x minus 4 all divided by 5x minus 10 minus 2x plus 4, make sure you distribute that negative with it, all over x minus 2 times x minus 4. Okay, so again, once I get a common denominator on top and a common denominator on bottom, that's when I'm going to leave, change, flip. So combining like terms, I get 7x minus 20 over x minus 2 times x minus 4 times x minus 2 times x minus 4 all over, combining like terms, I get 3x minus 6. Okay. So those things drop. And I'm left with 7x minus 20 over 3x minus 6. Again, if there was anything possible to factor out and cancel, I would. I could factor out a 3 on bottom, and that's going to leave you with an x minus 2, but there's no way to factor out a 3 on top, and there's no way to make an x minus 2 on top, so there's really no point to doing that. Okay? All right, last one. Okay, this one's just a little more complicated because I've got 3 fractions on bottom, or 3 things on bottom, but it's a little nicer because it's going to have a common denominator of x minus 6 on both top and bottom anyway. Okay, so let's start this one off, getting our common denominators. So I've got x minus 6 over x minus 6 for the 1, plus 9 over x minus 6, all over, okay, that's going to be x times x minus 6 over x minus 6 plus x minus 6 over x minus 6, maybe, minus 18 over x minus 6. Okay. So let's combine everything together that we can, distribute if we can. So this is going to be x plus 3 over x minus 6 all over x squared minus 6x plus x minus 24. Yep. All over x minus 6. Okay. Leave change flip now that I've got a common denominator on top and a common denominator on bottom. Now remember, it doesn't have to be the same, although in all these examples it has been. Combining like terms down here, this is what I get. Okay. Now again, just like on all the other ones, these two things cancel. It will not always happen, but it will usually happen. And I'm left with x plus 3 over x squared minus 5x minus 24. Now, let's see. Factors of 24, can they get me to 5? If I do a negative 8 and a positive 3, yep, that gets me there. Okay, so this is x plus 3 over x plus 3x minus 8. Because negative 8 times positive 3 gives me that negative 24. Negative 8 plus 3 gives me that negative 5. So let's cancel. And I'm left with 1 over x minus 8. Okay? Alright, so in summary, what you're going to do is you are going to start by getting a common denominator on both top and on bottom. It does not have to be the same denominator on top and on bottom, but sometimes it is, sometimes it isn't. Okay, most of the time it is. Once you get that common denominator and combine all your terms on top and bottom, you're going to leave change flip. In other words, multiply by the reciprocal. Okay, you're going to multiply by the reciprocal, cancel out anything you can. If you can factor, try it and see if you're going to be able to factor anything out. But if you can't, sometimes you just have to leave it kind of crappy. Okay?